Hello everyone, welcome to my channel, and today I'm going to teach you about plane stress problems using Comsol Multiphysics. So this is the plate that we are going to analyze. There is a hole in the center, and the plate is of 1 centimeter thickness, of dimension 100 centimeter by 200 centimeter, and it is subjected to a uniform stress of 100 Newton per centimeter square on both sides. So the modulus value is given is 20 10 to the power 6, and due to symmetry we need only to model 1/4 of the plate. Now we'll go to the software to analyze this plate in the software. So go to model wizard, select 2D, from here solid mechanics, and add or double click or add solid mechanics, then go to study. My computer is slightly hang, so yeah, I hope it works better on yours. So select stationary in the select study tab or these options, and then click done. I don't want to save my previous work that I was working on it. Now the first thing I will do is work with my units. So what I will do is I will select my units as none, so I will trace my units by myself. So in the next step we'll just model the plate. So go to rectangle, I'm going to model 1/4 of the plate. So and I'm taking on the left bottom corner as reference, that are at the coordinate 0 0, and the width is 100, height is 50 for 1/4 of the plate. So also I need right click on geometry, select circle, and make the center of circle lie at 0 0. Okay, so put the radius as 10 and then build selected. Okay, now I want to remove the material in the left bottom corner. So what I will do is I will go to geometry and right click on it, select boolean, and then select reference. So in this object to add table I will select the objects that I want to keep, and in the object to subtract table I will select the objects that I want to remove. So then build selected. Okay, now you need to specify the type of problem. So go to solid mechanics, and in here you can see there is a 2D approximation, and from the 2D approximation let's select the plane stress. So because the problem statement says that we have to do the plane stress analysis, so just select plane stress, and in here the thickness is 1 centimeter. Okay, just put 1. Now we'll define the material. So go to material, right click and blank material, then put Young's modulus value, and it's 2 to the power 2 times 10 to the power 6, and Poisson's ratio at 0.33, and the density is 2900. So in the next step we will define the boundary conditions and loads. So go to physics tab on the right side, and then click on boundaries and symmetry. So we will define the edges about which this plate is symmetric. So this is 1/4 of the plate which is symmetric about these two lines. That's it. Now we will also define the boundary load. So go to physics tab and boundaries, boundary load. Just select the boundary load. Okay, so in here select the side in which the load is given. So in here we can see on the right there is a load of 100 Newton per centimeter square. So just be careful with the unit. Is it per unit area or per unit length? So select as per given in the question. So it is in the x direction and it is towards the right, so the value is positive. Now right click on mesh and select free triangular mesh. Now go to size and from normal select fine. then build all. Now you can see that your plate has been meshed. We will provide very fine mesh near the hole because it is the most stressed area. So right click on mesh 1, more options, operations, then go to refine. Now in the refine setting window, go to the refine element in box. So in some version of the software, we can just select the region from the screen, but also we can go through the coordinates. So here we will go to the coordinates and click on draw box, then we'll go to the build all option at the top, and yep, we'll click the build all. Thus we can see that the region near the hole is been redefined. Now we'll go to study and just click on compute. So here we can see the deformed diagram of the plate. Over here the red color is the most stressed region and dark blue is the least stressed. Now right click on results and go to 2D plot group. Right click on 2D plot group, then select surface. Over here on this corner, go to solid mechanics and then select the stress edge and select von Mises stress and then plot. So this is the von Mises stress. Now if we want the value of these things, go to 2D plot group, right click and in here more plots, maximum or minimum line, and do the same thing. Go over here, solid mechanics, stress, von Mises stress, and then plot. Now you will see the values of the stress on the surface of the plate. The values shown here are the maximum and minimum stresses on the plate. So similarly you can do the repeat the process for other stresses as well, like the principal stresses and or any other stresses that you want. So now I will show you how to get your principal stresses. So for that, right click on results, 2D plot group. So right click surface and go over here, solid mechanics, stress, repeat again, stress, principal stresses, and let's select the first one, plot. Now again go to 2D plot group and select more plots and maximum minimum line and select the principal stresses similarly and plot. So now you can see the value of maximum and minimum principal stresses in the surface of this plate. Okay guys, thank you for watching my video. Hope you liked it, and if you want to see more videos like this, please subscribe my channel and have a blessed day. Thank you.